Hello, this is Algebra Lesson 2, Add, Subtract, and Multiply Polynomials. To start off, we're just going to go through a quick little exercise, and we're going to try and write the opposite term for each of the following polynomials. So we have 3x plus 2. The opposite term will be, if I added them together, they'll equal 0. So for 3x plus 2, I'm going to add the term negative 3x minus 2, so that when I add them together, it will be 0. So 3x minus 3x, 2 minus 2 gives me 0. What about negative 4 plus x? Sorry, negative 1x plus 4. Well, it's going to be x minus 4 as its opposite term. And the last one, 5x squared minus 3. Well, if I add negative 5x squared plus 3, I'll get 0. So this is just a quick little exercise in the opposite term. Now moving on, if I want to add polynomials, I'm going to remove the brackets and I'm going to collect like terms. Like terms have the same variable. So in this case, like terms in my first example are 2x and 4x. 3 and 2 are constant terms. They're also considered like terms as well. So they also have to say the same variable and same exponent. So x squared and x are not like terms. So it has to have the same variable and has to have the same exponent. So for my first method, I'm going to remove the brackets and I'm just going to collect the like terms. So I'm going to rewrite it 2x plus 3 plus 4x plus 2. 4x, 2x are like terms, 3 and 2 are like terms. So I'm going to rewrite this so that all the like terms are beside each other. So this is 2x plus 4x plus 3 plus 2. And I'm just simplifying this as much as I possibly can. Since it doesn't have an equal sign, I can't really solve for it, I can't evaluate it, I can only simplify. 2x's plus 4x's gives me 6x's. 3 plus 2 gives me 5. So that's a pretty common way of doing it. Removing the brackets, collecting my like terms, making sure they're beside each other, and then just simplifying it, doing any of the addition or subtraction. And what about my second example? I have 5a plus or minus 4 plus x plus 5. The only like terms in this one are 4 and 5, but here I have 5a and x. They're not the same variable, so they're not like terms and I can't collect them. So first of all, I'm going to remove the brackets. I have 5a minus 4 plus x plus 5, and the only thing I can do, 5a plus x, can't do anything with that, but negative 4 plus 5, well, that I can actually do some math. Negative 4 plus 5 is 1. So in the end, I have 5a plus x plus 1 as my simplified expression. Can't go any further because a and x are not like terms, and I can't add or subtract them. The second method is if I just write it vertically. So write it like we used to do up and down. So I'm going to take my 3x squared plus 3, and I'm going to add it to 4x squared plus 7. Now when I write it vertically, I'm going to make sure the common or like terms are above and below each other. So I'm going to write it out, 3x squared plus 3 plus 4x squared plus 7. So my common terms are kind of aligned vertically like this. So I have 3x squared plus 4x squared gives me 7x squared. 3 plus 7 gives me 10. So it's very, very simple. I can just add them either doing like this, like vertically, or I can just remove the brackets and collect like terms. Those are our two methods so far. Now, if I subtract polynomials, it's actually just the same as adding polynomials, except for now I have this negative sign right here in between them. But really, all that negative sign is a -1. And I'm going to have to multiply everything to the right, or inside the brackets, by -1. So I multiply by -1. Because essentially, this is x plus 4 plus -1 times 3x plus 3. That's all it really is. So I'm just going to multiply everything inside this bracket to the right here by -1. So it's x plus 4, well that's actually not, plus -3x minus 3. I'm just going to move this over here because I'm running out of room. So I'll have x plus 4, I'll get rid of the brackets, minus 3x minus 3, and I'm left with x minus 3x plus 4 minus 3, and in the end I'm going to get x minus 3x, so I'm going to have -2x, 4 minus 3 plus 1. So here the first step changes in that I have to multiply everything to the right of the negative sign by -1, and then I just add them normally. Let's try this one. I have 2x squared minus 3x plus 4 minus -4x, or minus 4x squared minus 5x plus 2. So I'm going to multiply everything in this bracket by -1. So I have 2x squared, this stays the same. Now I have plus -4x squared, minus and minus becomes positive 5x, minus plus 2, -2. I'm going to remove my brackets, not add more. 2x squared minus 3x plus 4 minus 4x plus 5x, or squared, minus 2. Bring everything that's common together. So I have the x squared, so I'm going to make sure they're beside each other. 2x squared minus 4x squared. I also have the just x to the power 1 terms, minus 3x plus 5x, and then I have my constant terms here and here. So I'm going to make sure they're beside each other. 4 minus 2. 2x squared minus 4x squared, well, that just becomes -2x squared. -3x plus 5x becomes 2x. 4 minus 2 becomes 2. So when it's all said and done, when I break it down, I'll have -2x squared plus 2x plus 2. Again, key thing, multiplying by -1, everything in the bracket to the right. Now when I multiply polynomials, I'm going to use the distributive property. Now the distributive property, if you've seen this before, is actually a quick way to do some mental math. So if I'm going to do this calculation, 5 times 63, it's actually better in my head if I actually multiply it 5 times 60 and then add whatever 5 times 3 is. So it actually ends up giving me a much quicker way of doing things. So I can apply the same kind of distributive property principle to here. So if I have 3 multiplied by the binomial x plus 2, well, I'm going to multiply 3 by both x, and I'm going to multiply 3 by 2. So this is going to be 3 multiplied by x plus 3 multiplied by 2. In the end, I'm going to get 3x plus 6. So I multiply whatever is outside the brackets by whatever's inside the brackets. Here I have a -2 multiplied by x squared plus 6. So -2 times x squared, and then negative 2 plus 6. So that's going to give me, I'm going to write it down here, negative 2 x squared plus negative 2 times 6. So negative 2 times x squared, well, that just gives me negative 2x squared. Negative 2 times 6, well, that's negative 12. And that's like the distributive property, just multiplying whatever's on the outside by both things on the inside. We can work this also for variables on the outside. We just use exponent laws. So here I have x times x minus 4. That becomes x times x plus x times negative 4. Well, x to the 1 and x to the 1, well, 1 plus 1, the product rule is x squared. And there I have an x times negative 4. That just gives me negative 4x's. What about this one? X squared times 3x plus 2. And I have x squared times 3x plus x squared times 2. X squared times 3x. So this is actually going to be 1 times 3, and then x squared times x. Well, that's 2 plus 1, x to the third, plus 2x squared. Same thing here with the negatives. We always want to be careful with negative signs. They tend to mess us up if we're not paying attention. I have negative x, brackets are helpful here, times 2x plus negative x times negative 7. I always want to try and keep the signs together. So negative 1x times 2x gives me negative 2x squared. Because this is not negative x, it's negative 1 times x. Over here I got negative x times negative 7 gives me positive 7x. So this one you always have to be careful of the double negative sign.